Okay, I is 5 times v minus u. V is 14 to two significant figures and u is 8.7 to two significant figures. Work out the upper bound for I. Right, upper bound, so we have to make I as big as possible. So this has to be as big as possible. That means the thing in brackets has to be as big as possible. To make that as big as possible, because v is positive, we have to take the upper bound for v to make that as big as possible. But because we're subtracting u from v, the smaller u is, the bigger this whole thing is. So we have to take the lower bound for u. Okay? So we're going to take the upper bound for v and the lower bound for u. Okay, that's important. Don't fall into the trap of taking the upper bound for both of them. Yes, it's asked for the upper bound for I, but that doesn't necessarily mean you take the upper bound for everything on the other side. Just to recap, we want to make this whole thing as big as possible. So that means v has to be as big as possible, but because we're subtracting u, it has to be as small as possible. Okay, so we need the upper bound for v. V is 14 to two sig figs. So that means v could be rounded down from 14.5. That's as big as v can possibly be, because if it's 14 after rounding, if it were 14.6, you'd round up to 15. So 14.5, actually, you would round up if it was 14.5. You're quite right, you would round up to 15. But that's as big a value as it can be. So just take 14.5 as the upper bound. Don't think about that too much. You're right, you would round up to 15, but it's a boundary value. So just take it as 14.5. That's the upper bound. Right, the lower bound for u. U is 8.7 to 2 sig figs. So 8.65 must be the lower bound, because anything lower than that we would round to 8.6, not 8.7. So put those two values in here. I is 5 times 14.5 minus 8.65, and that is 5 times 5.85, which is 29.25. And that's it. That's the upper bound for I.